Okay, so let's just jump right in. We've all seen those incredible, mind-blowing videos the AI can just create out of nothing. But today, we're going to look past the pretty pictures and ask a much, much deeper question. Can these AIs actually reason about the worlds they're building? Because, that's the next great frontier. I mean, the progress has been absolutely breathtaking, right? You have models like OpenAI's Sora or Google's Veo, and they can take a simple line of text and just spin it into these photorealistic, high-def videos. They're literally creating worlds that look and feel completely real. It's a massive leap forward. But, and this is the big but, here's the beautiful blind spot. While these models are masters of making things look good, they often have zero fundamental understanding of the scenes they create. They don't really get basic physics or causality or even simple logic. It's like, yeah, they can show a ball bouncing, but they don't know why it bounces. So, how in the world do you teach an AI to actually think? Well, a huge team of researchers decided to go back to the drawing board, and they looked at how we humans do it, our own cognitive architecture. They broke down this really fuzzy idea of reasoning into a set of core teachable skills. And this is what they came up with. 5 pillars, the building blocks for intelligence. It's not just one giant skill, right? It's a bunch of different faculties all working together. For today, we're going to zero in on 2 that are super interesting when it comes to video. Let's start with transformation. First up, transformation. The easiest way to think about this is as the AI's imagination. It's the ability to mentally rotate things, move them around, and kind of play with objects in its mind's eye to figure out what's going to happen next. It's not just about seeing what's there, but imagining what could be there. So take this puzzle, for example. To solve this, an AI can't just guess. It has to look at these 4 L-shaped pieces and actually simulate, in its head, rotating each one until they click together perfectly to make a square. It's a pure test of that internal modeling ability. Okay, next up is spatiality. This is all about an AI's intuitive grasp of space. Think about how you just know the layout of a room or how to get from point A to point B without walking into a wall. That's spatiality. It's that fundamental understanding of places and paths. And a maze like this one, it's the perfect test for it. The AI gets a start point and an end point. Its job is to figure out the most efficient way through, understanding that those dark walls are solid obstacles. This is just pure spatial problem solving. So here's the thing. To teach these skills, you can't just show the AI a few examples. It needs a place to practice. A lot. So researchers built exactly that. They built a massive, custom-designed dataset that's basically a giant cognitive gym for AI. And when I say giant, how big are we talking? Well, it's about 1,000 times larger than all the other major video reasoning datasets put together. We're talking more than 1 million video clips, all designed specifically to teach and test these cognitive skills. The scale here is just completely unprecedented. This visual really just drives it home, doesn't it? That huge circle in the middle, that's the new data set. And all those tiny little dots around the outside, yeah, that's the 9 other major data sets in this field combined. It's a whole different league. Okay, so you've built the world's biggest AI gym. The big question is, does the workout actually work? So the researchers took a really powerful open source model and put it through its paces on the new dataset. And, well, the results were pretty staggering. Just look at this jump. The base model started with a score of about 0.37. After being fine-tuned on this new dataset, its score rockets up to almost 0.7. That's a relative improvement of over 84%. The training didn't just help a little. It fundamentally transformed the model's ability to reason. And this is where it gets even more interesting. The model trained on this new dataset didn't just get better, it actually blew past leading proprietary models like Sora 2 on this specific benchmark, especially in areas like spatiality. But, and this is important, look at the human score at the bottom. There is still a big gap. It just shows how hard this problem really is. So what does this improved reasoning actually look like? Well, check this out. In the top left image, Sora 2 is asked to remove the symbol with the red border. It gets it, but notice how it also messes with the other symbols. But on the right, the model trained on the new dataset does exactly what it was told. It removes only the target symbol and leaves everything else untouched. That precision is the whole ballgame. And this quote from the paper just sums it all up perfectly. If a model can't reliably control the scene and follow your instructions to the letter, you can't really prove its reasoning. It might just be getting lucky, making a pretty picture that happens to look right. This controllability, that's the foundation for everything. So, why does any of this matter? I mean, who cares if an AI can solve some abstract puzzles? Well, because this is about getting AI to move beyond just spitting out pixels to actually understanding what those pixels mean. See, this research is what lays the groundwork for an AI that can be genuinely helpful. An AI that gets cause and effect, that can follow complex, multi-step directions, and that might one day be able to safely and reliably interact with the physical world. This is how we get from cool creative tools to truly capable partners. And that brings us to the final thought I want to leave you with. For years, AI has been learning from our world, crunching all our text and all our images. But now, it's starting to develop a foundational, almost intuitive kind of reasoning about our world. So the question isn't if it will understand, but what happens when it really, truly does.